So on this, we were learning on Desmos how to move a parabola. So what a regular parabola is, it's centered at 0, 0, that's its vertex. If I go out 1 squared is 1. If I go out 2 squared is 1, 2, 3, 4. So however far I'm moving from my vertex, I take that number and I square it. That's how high I'm going for any parabola that's just being translated, but I'm not changing the shape of it. So on these ones, we're trying to figure out if I want to keep this parabola as is, my basic x squared, and I want to move it up or down, what's going to happen is for the blue one, I would go y is equal to x squared, and then to get it moved up to 3, I'm going to go plus 3, and that's going to shift that whole x squared graph up 3. Okay, it's the same exact graph. I'm just translating it up or down, and then we're going to try left or right. So for this orange one here, I would do y is equal to x squared, and then that one I'm going to go minus 3, and that's going to move it down 3. Now, to move it green or purple, when I want to move it left or right, I want my 0 squared to be located right here. So basically, I want to get a square of 0 right here at 4. So I have to adjust my x so that when I put in a 4, I get a 0 before I square it. So for the green one, I'm going to go y is equal to the quantity x minus 4 squared. Because if I put a 4 in here, 4 minus 4 is 0, 0 squared is 0. And so this is now going to be shifted over here. If I want to move it to negative 4, again, I want a negative 4 to make my quantity being squared 0. So this time I'm going to have y equal the quantity x plus 4. Because a negative 4 makes this 0, I square it, I end up with, I square this and I end up with a 0. Okay, so adding or subtracting, the quantity being squared moves it up or down. Whatever makes this 0, that's the direction horizontally, left or right, that you've moved the graph. So on one like this, each of these, the vertex is going to be remaining right here at 0, 0. We're going to be changing the stretch of this, okay? Now, for this, what you'll notice is if I went out 1 from my vertex, 1 squared is 1. So normally I should have been right here. But instead, I was up at 3. So when I went out 1 and squared 1, I then times that 1 by something to get here at 3. Well, I tripled it. So that's why we have a 3 here. That's our stretch. So when I'm trying to do my blue one, okay, and let me just get the value here. So I'm at 5, 5. If I go out 1, 2, 3, 4, 5, 5 squared is 25. I should be going up a height of 25. I'm not going up a height of 25. I'm only going up 5. So again, if I went over 1, 2, 3, 4, 5, 5 squared, I should have gone up 25. So if I take 25, which is how high I should have gone up, times it by some a, and I end up going up only 5, I could actually solve that. And so when I divide both sides by 25, I get 5 over 25, or I get 1/5. So that's what my a is. My a is 1/5. Some of us did it as a decimal, maybe guessing and checking, but if I count 1, 2, 3, 4, 5, and I should be going up 5 squared, which is 25. I only went up 5. I went up 1/5 of it. So I'm going to go y equals 1/5 x squared, and you see it went through. Let me just get these other values up here so I can see these. Okay. And do a new one so I can have all that on my screen. Okay. So for the green one here, if I go out 1, 2, 2 squared should have been 4. So I should have gone up 1, 2, 3, 4. That's where I should have been for a normal x squared graph. Instead, I went down 1, 2, 3, 4. So since I went down 4, that means it's going to be a negative. So this is going to be y equal negative x squared. And you see that it did go through there. Okay. So again, I'll just jot that down here. So this one was y equal negative x squared. So then for my orange one, if I go out 1, 1 squared should be 1. I should have been right here, up at 1. I wasn't. Instead, when I went 1 squared, I went down 2. So really what's happening is I'm taking 1 times a negative 2. That is going to be my stretch. So I'm going to put in y equal a negative 2x squared. And when I do, it did go through that orange one. So now my purple one. So again, this was y equal a negative 2x squared. Okay. So then my purple one, for this one, I go out 1, 1, 2, 3. 3 squared is 9, but I didn't go up 9. I went down a negative 1.5. So I should have gone up 9. I'm timesing 9 by something to get a negative 1.5. Let me make that a darker purple. Okay, so then I'm going to divide this by 9. I'm going to divide this by 9. And if I take negative 1.5 over 9 in my calculator, negative 1.5 divided by 9, I end up getting a negative 0.6 repeating. But if I hit my math button and I change it to fractions, I actually get that my a is a negative 1/6. I get a negative 1/6. I'm 1/6 as high. So if I put in, and again, I think I might even do it here. Let's see, negative 1.5 divided by 9. Did it give, okay, it gave me that. Should be able to change it to a fraction here. I guess it didn't let me. We can normally on our thing. So this is going to be y is equal to negative 1/6 x squared. And check my work. Whoops. I did not get out of my denominator. X squared. And when I check my work, you see it went through it. So some of us might have gotten these using decimals and kind of guess and checking. But if you think about where your vertex is and you think about a regular parabola, I do 0 squared, which is my vertex. 1 squared is 1, 2 squared is 4, 3 squared is 9. So when I go out 1 and 2 and 3, think about how I've changed how high or how low I went. And so again, if I went out 1, 2, 3, which is 9, and I only went down, when I went down negative 1.5, 9 times A equal however I went, do that math, and you'll get your 8. Okay, so now the next one. On the next one, they gave us our vertex. If you click on this, it'll give it to you to make sure. So this is our vertex. And it gave us these points here. Now, since I know that my vertex got moved from 0, 0 to the right 4, so to move it right 4, that's going to be y equal the quantity x minus 4 squared. Okay, that's going to move it to the right 4. Okay, I now need to also move this down 2. So to move that down 2, I'm going to go minus 2. So again, this moved it right 4. This is going to move it down 2. Now I need to work on my stretch. So to work on my stretch, one way to think about it is if I went out 1, 2, 2 squared should have been 4, but I didn't go up 4. Okay, I ended up going up 1, 2. So if I go out 1, 2, and I end up getting 2 squared is 4, and I only went up 2, that's half as high. I went half of what I should have. So my stretch is going to be, so my stretch is going to be a 1/2. And when I check it, you see it goes through. So I'm focusing on how to move it to this point, which is moving it right 4, down 2. And then from my vertex, I'm going, okay, how far out am I going? 1 squared is 1, but I didn't go that high. Couldn't really tell here. 2 squared is 4, but I only went 2. I went half. Okay. So on the next one, this one's slightly different. This one, we don't know the vertex, we know our x-intercepts. So since I know I have an x-intercept of -2, what factor gave me that? An x plus 2. So it has to be either the first one or the last one here. And then what gives me a x-intercept at 5? Well, a factor of x minus 5, because 5 would make that 0. Now, this is an open up parabola. This one here is a negative. That would be upside down. So it's going to be this one here. And then you would explain your reasoning. But again, to get this vertex, which is at -2, not vertex, but x-intercept at -2, I need that to make my factor 0. And I need the 5 to make the other factor 0. On the next one, Eric thinks the equation y equal x minus 3 squared will match with the blue one. Jenny thinks it will match with the red one. Well, you want to ask yourself, what will make this be 0 squared? 3 minus 3 will make this 0. So since 3 will make this 0, this one right here is the correct graph. So Jenny is right. Okay, again, because this 3 is going to make this 0, and your vertex is where your 0 squared is. Air quote 0 squared, because it's not at 0, but what makes it 0. On 8, so we have 3 different colored graphs here. They gave us these 3 equations. They wanted to go through -4 for an x-intercept and 3. So if I want all of these to go through -4, I need an x plus 4. So I'm going to change each of these to an x plus 4. X plus 4. X plus 4. And now they got at least it through this point here. Okay. Then I wanted to also go through at 3. So instead of this x minus 3, x minus 2, I need it to be an x minus 3. X minus 3. X minus 3. And now you see that all of these graphs go through these 2 x-intercepts, because -4 is going to make this factor 0 in each of these, and 3 is going to make this factor 0. You see the stretch changes the look of the graph, but your 0 is unaffected by that because 0 times anything is 0. So that's going to still remain your 0 no matter what your stretch is. On one like this, they wanted us to plot 5 different parabolas. You'll notice that each of these, if you're at the vertex, I'm going over 1, up 1, or over 1, down 1. So each of these has a stretch of 1, but some of them are positive 1 and some of them are negative 1. So we're really concerned with having them open up or down in terms of their sign. And we're concerned about where to move them to. So let me just get their vertex up here so we can see them. So if this vertex is at -6, -1, I basically want to move it left 6 and down 1. So to move it left 6, x plus 6 is going to move it left 6. Okay. I also want to move it down 1. So then I'm going to put my -1. So whatever makes this 0 is your left-right movement. Since -6 makes it 0, I'm moving 6 to the left. And then -1 drops it down. So this one here, what I'm going to do is this one needs to be moved to -3 and a positive one, but it needs to open down. So this is going to be y equal negative to make it open down. That is not going to affect the left-right movement. If I want to have it at -3, I still need this to be an x plus 3. Because -3 will make this parenthesis 0. The negative outside does not change that direction. And then I need it to be a +1. And there you go. This one here, just dropping it down 1. So this is going to be y equal x squared -1. And we're moving it to the right 3, up 1, and then flipping it. So to flip it, I'm going to put a negative. To move it to the right 3, x minus 3, because 3 will make x minus 3 0. Again, this negative will not change that. And then I want +1. And then the last one here, 6 -1. So y is equal to the quantity x minus 6 squared. That's going to move it right 6 and then down 1. Okay, just having you practice left, right, up, down, flipping. Okay, now this one here, they want us to have all these parabolas, 5 total. One of them they filled in for us, going through these vertices and going through these points. So let me just get these vertices up so I see them. If you click on them, you can see them. And each of these is going to go through these points here. So each of these is going to have an x minus 4, x plus 4. So let me just, I'm just going to plot that. I'm going to adjust it here in a second. Okay. So right now I have this one because I made all of these be the same, but I'm just trying to get my x-intercept. So all of them will have an x-intercept at -4. So that's going to be from the x plus 4. All of them are going to have an x-intercept at +4, comes from the x minus 4. Now I'm going to work on the stretch. So let me just get these points again so we can see them. Okay, and let me just get this so I can write. So I am trying to get these various points here. So for this, couple ways you can think about this. If I want these to be the vertices, so I want this vertex to be at 0, 80. So what I'm going to do is I'm going to count. I'm going out 1, 2, and I'm going to draw it here. I'll draw it in red. I'm going to go out 1, 2, 3, 4, and basically down 80. Okay, now when I go out 4, I should have gone 16. Okay, because 4 squared is 16. So if this was my vertex, I should have gone out 4, and 4 squared is 16. I should have gone up 16. I didn't. I went down 80. So what am I timesing A by to get a negative 80? Because that's where I really went. I didn't go up 16. I went down 80. So if I divide by 16, I end up with a negative 5. My A is going to be a negative 5. I'll write these out here in a second. For my blue one, which is 48, if I go out 4, again, I should have gone up 16, but I went down 48 because that's where my vertex is. So if I take 16A set equal to negative 48 and solve, I get that my A is a negative 3. For my orange one, if I go out 4 again, I went up I should have gone up 16. I only went up 32. So again, I took 16 times something to get me 32, and that's going to be a 2. From the purple one, again, I went out 4, and we went up 64. So 16A is equal to 64. My A is going to be 4. Again, each of these, I was 4 away from my vertex. So from that vertex, I should have gone up 16. But here I went up 64. Here I went up 32. Here I went down 48. Here I went down 80. That's one way to come up with your stretch. So let me just add those into our equation. Okay. So my red one was a negative 5. Okay. And you see that goes through those points. My blue one was a negative 3. Okay. And that went through. My orange one was a 2. And then my purple one was a 4. You could also put A in place of all of these and use 0, 80 and put it in for your X and Y and find your A. That's another way of going about doing it. But I want you guys also to understand, if you know your vertex and you know a point, you can kind of figure out what your stretch is. Okay. Now, on one like this, they are giving us these 2 points, okay, 2 x-intercepts. So I know for sure that I'm going to have y is equal to get the negative 6, x plus 6 gave me an x-intercept of negative 6. To get the 2, x minus 2. So if I see this, it's going to go through those points, but it's not going through this. Now, I don't know where my vertex is to kind of think about using my idea of its stretch to figure out this. So what I'm going to do is I'm going to substitute this point into my equation for x and y. So let me just get another copy of this. Okay. So if I know it's going to be y equal a times x plus 6 times x minus 2, and it has to go through negative 4, 3. This is going to end up being a negative, but I will find that sign when I substitute in 3 for my y and negative 4 for my x's. And so I'm going to get 3 is equal to a times 2 times negative 6. So I get 3 is equal to negative 12a. I divide by negative 12, and I'm going to get a negative 1/4 as my a. That is my a. So I'm going to put a negative 1/4 here. Oops, hold on, let me just move this. Negative 1/4. And you see it went through this. Now they wanted us to give a second equation. If I have this and I see my vertex is negative 2, 4, I'm going to write it from my vertex. My a is the same, whether it's in this factored form, in standard form, where it's all multiplied out, or in this nice graphing form, vertex form that we're learning. So if my vertex is negative 2, that means it's going to be an x plus 2 squared, and then plus 4. So I'm going to go y equal negative 1/4 is still my stretch to get my vertex that we said was at a negative 2. Let me just get this back. Negative 2, I'm going to have an x plus 2 squared, and then plus 4 to get it up 4. And you see it goes through it. Okay, I just found my vertex. I put it in vertex form. My vertex is moving to the left 2. That's what this does. It's moving up 4. That's what this does. And my stretch is still the same. You could also have multiplied this out and gotten x squared plus 4x minus 12, and then multiply everything by negative 1/4 and had it in that form. That would have been acceptable also. Okay. Okay, so I think this will be the last one we talk about, and then we're going to do some notes to make sure that we get our notes into our composition book. So if I have this one, which has a vertex at negative 6, 1, I know that y equal the negative 6 movement is going to come from x plus 6 squared. The plus 1 is going to move it up 1. So when I do this, you see it's in the right spot, but the stretch is off. Stretches off. So one way to think about it is I'm going to go over 1, 2, 3. 3 squared is 9. I did not go up 9. I went a third. And there's my graph. So again, I went over 1, 2, 3. 3 squared should have been 9. I didn't go up 9. I went 3. So you can do 9a equals 3 and solve. And you get 1/3. Now for this one, I can't really do it with x-intercepts. So if I am doing this, I'm just gonna so if I was doing this, I would actually work this out. Okay, so x plus 6 squared would be x squared plus 12x plus 36. That is x plus 6 squared. And then I'm going to add 1 onto that after I take a third of it, okay, because I still have my 1/3 in front. So my 1/3 is multiplying my x squared plus 12x plus 36. So I would get 1/3 x squared, and just make sure that that needs to be on the top, plus 4x plus 12 plus 1. And so my equation is going to be y equal 1/3 x squared plus 4x plus 13. That's going to be my equation. Okay. So y equal 1/3 x squared plus 4x plus 13. And you see I got the same thing again. Okay. So I know some of us may have had some more questions on this, but hopefully this kind of helps us understand the movement of it, how to find the stretch. And again, if you are having trouble understanding how I'm explaining that all parabolas are basically 0 squared is 0, 1 squared is 1, 2 squared is 4. If I go out 1, 1 squared is 1, I should be here. If I'm not, I times that by something to get the height I'm at. So if I went out 1, 2, 3, 3 squared is 9. I times 9 by something to get only 3. 9 times a third. But you could take a point, this point here, which is negative 3 comma 4, and you could put it into your equation to find your stretch. Put an A there and put it in for your X and Y. Okay, so now let's take out our composition book and we're going to do some quick notes. So graphing parabolas in vertex form. So first thing I'm going to do is just graph our parent equation of a parabola. So the parent equation is y equal x squared. And if you're graphing y equal x squared, you have a vertex at 0, 0. Now for this, I want us to be able to get at least 9 above my x-axis. I really don't need to be below the x-axis for this graph right now. So when you graph this, just make sure you can get up 9, okay? And so when I graph this, I'm just moving it over a little bit, a little thicker. So when we're graphing this, you want to think about I am going to be graphing my parabola, my basic parabola. 0 squared is 0. So I have a point at 0, 0. Okay, let me zoom in a little bit. 1 squared is 1. So if I go out 1, I'm up at 1. If I go out 2, 2 squared is 4. So I'm going to go up 1, 2, 3, 4. If I go out 3, 1, 2, 3, 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. And when I square a -1, I also get 1. When I go out -2 and I square a -2, I get also a 4. And -3 squared is 9. And so there's my parabola. So again, I'm at a height of, let me just write these so you can see these values, but I'm thinking about how far out I'm going. So this one's at 3 comma 9. This one's at 2 comma 4 because 2 squared is 4. This is at 1 comma 1, -1 comma 1, -2 comma 4, and -3 comma 9. And then I'm going to draw my parabola, which is a U shape, not a V shape. We're going to learn that that's an absolute value graph. And there's my graph. Okay. Now I'm going to write our general equation of a parabola here on the side. And so our general equation, and if you need to write it below, that's okay. Our general equation is going to be y equal a times x minus h squared plus k. That is our general equation. Okay, that is our general equation. And your vertex is whatever makes this 0, which is h, that is going to be the x coordinate. And then whatever's happening here, I'm going plus k, up k, that is my y coordinate. That's where you find your vertex. Also, axis of symmetry is a line that cuts your graph in half. It is going to be a vertical line. So vertical lines are always x equal. And since it's at x equal, it has to go through this x coordinate. It's going to be x equal h. Now I'm going to talk about my A and real quick. So my A is our stretch. And depending on our A, it's going to tell you the direction that your graph's opening. If my A is positive, so if A is greater than 0, we say it opens up. Like that. Does everyone have the graph where I can just kind of zoom in on this? Or a little bit? Okay. So if my A is less than 0 or negative, it opens down. Now, my A also determines the stretch of this, narrower or wider. Now, it doesn't matter if your stretch is a +5 or a -5. Both of them will be the same narrowness, but one will be opening up, one will be opening down. So I'm going to write in absolute value. If your A in absolute value is greater than 1, we say it is narrower. And sometimes you'll hear that that is vertically stretched. That's how our book a lot of times will refer to it, vertically stretched. Move this up a little bit. If our absolute value of A is between 0 and 1, some fraction or decimal between 0 and 1, that is going to make it wider or vertically compressed. Okay. That's all dealing with our A. Now, if I'm talking about the x minus h squared or x plus h squared, if it's a plus, this is going to be your left-right movement. If it's an x minus h, h will make that 0. So that means it's going to go right h units. Negative h would make x plus h 0. So you're going to go left h units. And then the plus k or minus k. If it's a plus k, that's going to make your graph go up k. And if it's a minus k, your graph's going to go down k. Let's say that I have us do y equal 2 times the quantity x plus 3 squared minus 5. So if that is our parabola that we're doing, our vertex is going to be, because of the x plus 3, -3. Because of that minus 5, -5. That's where my vertex is. And my stretch is going to be 2. So I'm going to kind of shrink this a sec so I can get my graph in here. Okay. So when I'm graphing this, my vertex is going to be at -3, -5. So I am going to go to -3, -1, 2, 3, 4, 5. That's where my vertex is. Now from here, my stretch is 2. So you're still thinking from my vertex, I'm going to go out 1. 1 squared should have been 1. I'm going to double it because of the 2. I'm going to go up 2. Same on both sides. I'm going to go out 2. 2 squared is 4. I'm going to double that because of the 2. I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go out 3. 3 squared is 9. I'm going to double 9. I'm going to go up 18. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then we're going to draw that. So then I'm going to connect these points with a U, and there is my parabola. Again, when I'm trying to find these values, I'm thinking about just doing a normal parabola, which is 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. That's the heights I should go to. When I go out 1 from here, I should have been up at 1. But the reason I did not was because I have a stretch of 2. So what happens is when I go out 1, 1 squared is 1, I'm going to double that. So I'm going to go up 2. When I go out 2, 2 squared should have been 4. 1, 2, 3, 4. I'm going to double that. So I went up 8. When I go out 3, 1, 2, 3, 3 squared is 9. So I should have gone up 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm going to go up twice as high. So I went up 18. That's how I'm getting these points. So one more graph. Let's try y equal a negative 1/2 x minus 4 squared plus 6. So the vertex for this is going to be 4, 6, because the 4 is going to make this 0, plus 6 because that's going to go up 6. My stretch, so this is my vertex. My stretch is going to be a negative 1/2. So when I'm thinking about doing my 0 squared and 1 squared and 2 squared and 3 squared, and I'm going to multiply it by the stretch, I'm going to be multiplying these by a negative 1/2. So I'm going to go half as high. Okay, 4 squared would have been up at 16, but I'm going to go half as high. So on this one, what I'm doing is, let me just get my graph. So my vertex is going to be at 4, 6. So I am going to go to 4, 6. 1, 2, 3, 4. 1, 2, 3. Actually, let me, this is negative. Let me move this up a little bit. Forgot where I was going. Okay, so I'm going to have it more centered here. Okay, start again. So I'm going to be going to 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And when I go out 1, 1 squared is 1, but I'm going to times it by a negative 1/2. So I'm going to go down negative 1/2. I'm going to go out 2. 2 squared should have been 4, but I'm going to times that by a negative 1/2. So I'm going to go down negative 2. I'm going to go out 3. 1, 2, 3. 3 squared should have been 9. I'm going to times it by a negative 1/2. So I'm going to go down 4.5. 1, 2, 3, 4 and a half. And if I go out 4, 1, 2, 3, 4. 4 squared is 16. I'm going to times that by a negative 1/2. I get a -8. 1, 2, 3, 4, 5, 6, 7, 8. And I'll do the same on the other side. And then I'm going to connect this with my curve. And that's my graph. So hopefully this helps you guys out.